Phenols are the organic compounds containing benzene in ring-bonded to hydroxyl group. They are also known as carbolic acid. They exhibit unique physical and chemical properties in comparison to alcohol. These physical and chemical properties of phenols are mainly due to the presence of hydroxyl group. Moreover, phenols can also be described a family of organic compounds characterized by hydroxyl OH group attached to a carbon atom that is part of atomic ring. Besides serving as the genetic name for the entire family, the term phenols also the specific name for its simplest member, monohydroxy. Benzene, also known as benzenol or carbolic acid. On the other hand, the chemical properties of phenols, it is presence of OH group on benzene increases. The electron density on the benzene ring making more susceptible to attack by an electrophile. The reaction involving benzene ring are electrophilic substitution reaction. Phenol contributes a major part of organic chemistry. They are considered as a class of chemical compounds which are bounded with the hydroxyl group and are attached to the carbon atom of the atomic ring. Phenol has a hydroxyl group that is always bounded with the benzene ring known as an atomic hydrocarbon group. Phenol is also referred to as phenolic, benzenol, or carbolic acid. At the end of this chapter, the student will be able to, number 1, identify the function of phenols. Number 2, discuss some prominent physical and chemical properties of phenols.
Phenols are the organic compounds containing benzene ring bonded to a hydroxyl group. They are also known as carbolic acid. They exhibit unique physical and chemical properties in comparison to alcohol. These physical and chemical properties of phenols are mainly due to the presence of the hydroxyl group. Phenols are similar to alcohol but form stronger hydrogen bonds. Thus, they are more soluble in water more than alcohol and have higher boiling points. Phenols occur either as colorless liquid or white solids at room temperature and may be highly toxic and caustic. Phenol may have been the first surgical antiseptic. At the end of the lesson, the students will be able to describe the physical properties of phenol, discuss the chemical properties of phenols, write the same of phenols, draw the structural formula of phenols, elaborate the importance of phenols.
Hi everyone, good morning. I am Ana Jean Maribao, your reporter about the phenols. Phenols are extremely relevant chemical functionalities in natural, synthetic, and industrial chemistry. Their corresponding electron-rich anions, namely phenolates, are characterized by interesting psychochemical properties that can be dramatically altered upon light excitation. Specifically, phenolates become strong reducing agent and excited state and are able to generate reactive radicals from suitable precursors via single electron transfer processes. Thus, this species can photochemical triggered strategic bond forming reaction, including their direct aromatic CH functionalization. Moreover, substituted phenolate anions can act as photocatalysis to enable synthetically useful organic transformation. An alternative mechanistic manifold is represented by the ability of phenolate derivative to form ground state electron donor acceptor or EDA complexes with electron poor radical sources. These complementary scenarios have paved the way for the development of a wide range of relevant organic reactions. In this minor view, we present the main examples of this research field and give insight on emerging trends in phenols, photocatalysis toward richer organic synthesis. Some prominent physical and chemical properties of phenol are given below. Pure phenols is a white crystalline solid smelling of disinfectant. It has to be handled with great care because it causes immediate white blistering to the skin. The crystals are often rather wet and discolored, melting and boiling point. It is useful to compare phenols' melting and boiling points with those of methylbezanes. Both molecules contain the same number of electrons and are a very similar shape. That means that the intermolecular attraction due to van der Waals dispersion forces are going to be very similar. The reason for the higher values for phenols is in part due to permanent dipole attraction due to the electronegativity of the oxygen, but is mainly due to the hydrogen bonding. Hydrogen bond can form between a lone pair on oxygen on one molecule and the hydrogen on the OH group of one of its neighbors. Number 2. Solubility of phenols. The solubility of phenols in water is governed by the hydroxyl group present. The hydroxyl group in phenols is involved in the formation of intermolecular hydrogen bonding. Those hydrogen bonds are formed between water and phenol molecule, which makes phenol soluble in water. However, the early group attached to the hydroxyl group is hydrophobic in nature. Thus, the solubility of phenols decreases with the increase in the size of the early group. Phenol is an organic compound appreciably soluble in water with about 84.2 g dissolving in 1000 ml. Homogeneous mixture of phenol and water at phenol to water mass ratios of 2.6 and higher are possible. The sodium salt of phenol, sodium phenoxide, is far more water soluble. Number 3. Acidity of phenols. Phenols react with the active metals such as sodium, potassium, and etc. to form the corresponding phenoside. This reaction of phenols indicates each acidic nature in phenol. The sp2 hybridized carbon of the benzene ring attached directly to the hydroxyl group act as an electron withdrawing group. This decreases the electron density of oxygen due to the delocalization of negative charge in the benzene ring. Phenoside ions are more stable than alkazide ions. As a result, phenols are more acidic than alcohol. In the case of substituted phenols, the acidity decreases if an electron donating group is attached to the ring, while the acidity increases in the case of an electron withdrawing group. Phenols are stronger acid than the alcohol, but they are not still quite weak acid. Phenol is more acidic than cyclohexanol and dicyclic alcohols because the penoside ion is more stable than the alkoxide ion. Number 4. Chirality of phenols. Phenols are exhibited chirality within their molecules, for example, catechin. This chirality is due to the absence of planar and axial symmetry in the phenol molecule.
Phenols are molecules that have hydroxyl group attached to the carbon atom of an aromatic ring. By definition, phenol is hydroxybenzene. Phenols is common name for compounds. Its IUPAC name would be benzol, derived in the same manner as IUPAC name for aliphatic alcohols. When the phenols molecules is substituted with additional groups, either the ortho, meta, para system of the numbering system can be employed in either case. If the parent molecule is referred to as a phenol, the nomenclature being used is the common system. In IUPAC nomenclature, the parent molecule is called benzenol, and the substituent are always numbered, with the OH group being given the understood first position. For the compounds below, the first name listed the common name and the second is the IUPAC name. Certain phenols are referred to by common names. For example, methyl phenols are called cresols. In the illustration below, the first name under each compound, it is common name, and the bottom name, it is IUPAC name. Similarly, hydroxyphenols have common names, which are listed first under each the following illustrations, while the IUPAC names are listed last. And for the summary, phenols, any of a family of organic compounds characterized by hydroxyl OH group attached to the carbon atom that is a part of an aromatic ring. Phenols are similar to alcohols but the stronger hydrogen bonds. Thus, they are more soluble in water than are alcohols and have higher boiling points. Phenols are similar to alcohols but from stronger hydrogen bonds. Thus, they are more soluble in water than are alcohols and have higher boiling points. Phenols occur either as colorless liquids or white solids at room temperature and may be highly toxic and caustic. Phenol consists of two parts, one aryl groups and one hydroxyl group. So based on the number of aryl groups attached, phenols can be further categorized as mono, di, tri, or polyhydric phenols. The IUPAC name for phenols is monodroxybenzene or C6H5OH. Nomenclature of phenols is considered as one of the major parts of organic chemistry. Phenols is common industrial as well as household product.